So, if you're a game developer, you know the struggle, right? We're always trying to hit these goals, like making a game fun or making the controls feel good. But those are feelings, they're totally subjective. So, how do you translate a feeling into actual concrete code that you can test? That's the big challenge we're going to dig into.
Yeah, this is the million-dollar question, isn't it? It's the problem every single one of us runs into. You can't just write a line of code like, if player is having fun, then true. It just doesn't work that way. We need some kind of bridge to get from the subjective experience we want players to have over to the objective nuts and bolts software we actually have to build.
And that leads us to this really core concept from game design theory called the second order design problem. You see, you can't directly engineer a feeling, like tension or responsiveness. It's impossible. What you can do, though, is engineer the mechanics, the underlying rules that cause certain behaviors to emerge, which in turn produces that feeling in the player. This is exactly the kind of problem the MDA framework is built to solve.
Okay, so how do we actually get a grip on this? Well, let's introduce the MDA framework. The best way to think about it is as a special lens, a way of looking at our game that helps us organize our thoughts and, build that bridge between our design goals and our engineering reality.
MDA basically says you can break any game down into three distinct layers. At the very bottom, you've got mechanics. These are the pure rules, the data, the algorithms, basically the code itself. Now, when a player starts interacting with those mechanics over time, that's when dynamics emerge. This is the runtime behavior, all the strategies that players come up with, the feedback loops. And finally, all of that together results in the aesthetics, the emotional punch, the feel, the actual experience the player walks away with.
And this slide, this right here, is the absolute key insight of the whole MDA framework. It shows this fundamental mismatch between how we, the developers, see the game and how players see it. We build from the inside out. We start with the mechanics to hopefully create some aesthetics. But players, they experience it from the outside in. They start with the feel, the aesthetics, and through playing, they slowly start to figure out the underlying mechanics. This disconnect is what makes game design so incredibly hard.
Okay, so that's the theory. That's great for a design discussion, but how do we make it, actionable? How do we actually take this high-level way of thinking and connect it to the day-to-day grind of writing code and shipping features?
So let's get one thing straight, and this is super important. MDA is a way to organize your ideas, not your code files. Seriously, don't go making folders in your project named mechanics or aesthetics. Instead, you use MDA as a conceptual checklist, a lens to make sure you're thinking about all three layers of the experience as you're designing. This is where we get disciplined. We connect that MDA lens to our actual code using a process called specification-driven development, or SDD. It's a pretty simple idea. Before you write any code, you first write a clear, detailed specification that describes exactly what a feature needs to do. And, crucially, it includes non-negotiable acceptance criteria. That spec becomes the single source of truth, the blueprint for everything else. And this just nails the connection, right? The MDA framework helps you think through what needs to even be in the spec in the first place, making sure you cover the rules, the emergent behaviors, and that final feel. Then, the spec itself translates all that thinking into a concrete, actionable blueprint that an engineer can actually build and, just as importantly, test against. All right, enough theory. Let's make this real. We're going to walk through a perfect example of how you can take a super vague, subjective goal about feel and turn it into something an engineer can build and, this is the key part, prove is working correctly.
So here's the scenario. Your designer comes to you and says, hey, when the player stops moving, it just has to feel stable and crisp. No weird sliding or drifting around. Okay, that's an aesthetic goal. It's totally subjective. How on earth do you write an automated test for stable stops?
And boom, here it is. This is the magic moment. This is where we translate that subjective feeling into an objective, measurable, and totally non-negotiable engineering contract. This is an actual acceptance criterion from a real spec. It's not an opinion anymore. It's a simple pass or fail condition. The drift is either less than or equal to 1 centimeter, or it's not. The test passes or it fails. End of story. You see how powerful this is? By defining stable with a hard number and then using telemetry, which is basically just logging data from inside the game, to observe it, we've actually made feel testable. This completely changes the conversation. It's no longer a subjective argument about what feels right. Now it's an objective discussion about why a specific test is failing. And it creates this incredible safety net that prevents someone from accidentally breaking that experience with a future code change. So let's put all the pieces together. Let's look at what a disciplined workflow looks like when you combine the design thinking of MDA with the engineering rigor of specification-driven development. What you end up with are two complementary loops that are basically mirror images of each other. The design workflow starts with the aesthetic, the big goal, and works backward to figure out the dynamics and mechanics needed to get there. But the implementation workflow builds forward. You start by coding the foundational mechanics, then you verify the dynamics that emerge, and finally, you validate that you actually hit the target aesthetic.
In practice, this means you build your features in layers. First, you nail down the mechanics. You get the core rules, the math, all of it locked down with really focused unit tests. Then, once you have that stable foundation, you start testing the dynamics, how things behave over multiple frames. And finally, you run your bigger integration tests to validate the aesthetics, checking against things like performance budgets and those objective criteria we put in the spec.
So why go through all this trouble? Well, the payoff is huge. You get three really critical things. First, determinism. Because you're building on stable, tested rules, you can evaluate the player experience repeatably. Second, observationality. Those vague feelings are now concrete data that you can actually measure and graph. And third, reliability. Those tricky, emergent behaviors aren't just a surprise anymore. They're explicitly tested to make sure they're stable.
And that brings us to the final thought I want to leave you with. Take a look at your own project right now. Think about a quality that you describe with a word like responsive or snappy, maybe tense or fair. Now ask yourself, how could you translate that feeling into a hard number, a measurable threshold that you could build an automated acceptance test for? Because that is where design truly becomes engineering.